Very exciting stuff. What up, people? This is going to be the Desmos live stream. Take a second to begin. Over in my bio or down below, you're going to be able to get a link to the Desmos worksheet that I'm going to be working throughout this lesson. And you guys can have it, keep it. It's free, but you'll be able to follow along yourself by downloading this guide. It'll be a full Desmos lesson. Hey, I'm alive. Look at that. Let me share my screen real quick. Sweet. So we'll get started here. If you guys go where the links are for YouTube or for TikTok, you'll be able to get a link to my Desmos guide where you'll be able to follow along with this. And then you're going to be able to complete the worksheet with me. And then you get to keep it. So you get to use it for your studying as you prepare for the SAT. I don't know if you guys are on the December one or if people are studying for March yet, but I know those are the two SATs coming up with a fat break in the middle. But I'll give it one more moment for you guys to get your guides and pull them up. But for TikTok, speaking to TikTok now, I have to use my phone due to technical difficulties. So I'm going to be panning like that. And so hopefully you guys will be able to follow along. But, yep. All right. I'll begin now. All right. Beginning the lesson in Desmos and how to use Desmos on the SAT. So Desmos is an incredibly important asset for getting a good score on the SAT. While it can't replace math knowledge, it can boost your score in algebra and advanced math particularly. It makes them a lot easier to do, saving you more or less a ton of time on the exam. And so I'm going to walk you through how to use Desmos on the SAT to get the hardest SAT questions right, fast, and efficiently, getting you far more points on the math section than you would have thought. So let's begin. You can see at the beginning of this, it's more of a walkthrough through Desmos. You're going to see kind of the different functions and buttons that are included on it. And then over here, I put a keyboard shortcut key. And so what's important about the shortcut key is that Desmos tends to take forever to click all the buttons. So if I open this right here, it would take forever for me to click greater than, less than, 2x plus 3x, yada, yada. And so this shortcut key is what I'll be using throughout the lesson, kind of walking you when I show you doing square root really fast or doing multiplication really fast. If you're wondering how I'm typing it, I have put all the shortcuts that I use there. But first off, let me walk you through more or less how to use Desmos. So in the beginning, what you really want to learn is where the buttons are. So you can see down here, you're going to have a keyboard that's going to be very similar to all the scientific calculators that you have used in the past. And why this one's special is because it has the a squared, greater than, less than, parentheses, etc. The only unusual thing about Desmos is that over here in the functions, you're going to have sine, cosine, and everything. So everything you need, so parentheses, absolute value, square root, to the power, all the different numbers, and then the addition, multiplication, subtraction, etc. The only thing you're missing is nth root, which is all the way in the functions down at the bottom, down here. And so that's all the important stuff where to keep track of for Desmos. All right, so that's where everything is on Desmos. And then I would absolutely recommend memorizing this keyboard shortcut so you can move faster during the exam rather than spending a bunch of time like typing and finger poking explanations. So let's scroll down a little bit in the Desmos guide. And we're going to be able to practice. So the first things that are by far the easiest to learn on Desmos are going to be these single variable equations on Desmos. They're very easy, and I'm going to walk you through how to do them. But there is some knowledge that you need to know for the exam in order to comprehend these. So for a single variable equation, you need to know that where the line crosses the x-intercept will be the solution to your problem. So if I had 3x plus 4 equals 0, and I said solve for x, normally you can do that algebraically pretty easily. But when you plug it into Desmos, where the line crosses the x-axis will be the solution. So in this case, the solution would be negative 1.3333333, because wherever it crosses the x-axis is the solution if you're dealing with one line. But there's definitely more complicated questions where this is really nice. So instead, say I said 3/4 plus 4/7. Rather than doing a whole bunch of horrible math, you can just plug that into Desmos and you have it right here, and you can pull it out and type that into your equation. Let's begin working on these problems. So single variable equations are equations with one variable, hence single variable equations. This first one we're going to attempt is 16x plus 24 equals 24x. So let's go ahead and type that into Desmos. 16x plus 24 equals 24x. So normally you're going to have to move that 24 around and you're going to have to plug that in, but you can see that instead of having to do a bunch of algebra by hand, I just typed it into Desmos and I can see exactly where it crosses the x-axis. That tells me that when Desmos solves this, x equals 3. That's how you solve these very quickly. You just plug them into Desmos and it'll spit out the answer because you can see where it crosses that x-axis. And so the answer to this question would be D, 3, and you could solve it in 2 seconds rather than doing algebra by hand. Now let's see where it gets a little bit more complicated. Take a look at the question at the right. You see this square root? Imagine doing that by hand. You're gonna have to square everything and then move it around. Big old pain in the butt. So instead, we can just type it into Desmos. So let me go ahead and do that. Square root of 2x plus 6. And I'm a big fan of when you're putting it into Desmos, just leave it as is. Plus 4 equals x plus 3. So I've typed that into Desmos, and you can see that I didn't have to do any math. It just spits it out, and I can see exactly where it crosses the x-axis. We can see that's going to split 4 and 6, meaning that 5 would be the correct answer. But let's pause here. I don't like vertical lines. So vertical lines sometimes don't give you a point when you click on them, and it's because it's a complicated equation. In this case, it's going to be a square root. And so Desmos is bugging out. It doesn't really know what to do. It's not finding an exact number, so it's not going to give it to you. And that could be tricky on some problems. Say if it was a fraction, you can't really eyeball where it is. So what you want to do is take the part of the equation that's smaller and you just want to move it to the other side. So in this case, if I have a positive x and a positive 3, what I want to do is just move it to this side so I can get rid of this vertical line and see the graph, and then it'll give me a point. All you do is just eliminate the equals and just put a subtraction sign. You basically just want to distribute the negative. And so as you can see, now I get my points, I get my normal line, and I can see that 5 is the exact answer. So once again, if you ever want to get rid of vertical lines, just go ahead and move some of the information all to one side and set it equal to 0. That's how you solve that problem. But imagine how long that takes you during the test to do by hand. Not fun. Let's take a look at this one. In the xy plane, line K has a slope of 5 and a y-intercept of 0, negative 35. What is the x-coordinate of the x-intercept of line K? In this case, what they're giving us here are all the things we need to know for y equals mx plus b equation. So they give us the slope and they give us the y-intercept. All we need to do is now make that an equation and plug it into Desmos. So it's going to look like this. You're just going to have the slope, 5 times x minus the y-intercept, which is negative 35, and you're going to get your line. And obviously, we can see that the x-intercept will be 7. We can solve that very quickly, or you can set this equal to 0. Obviously, add 35 to the other side, divide it by 5. Let's keep moving. So the one to the right, take a look at what is the solution to the equation below. And then we're given some radical fractions. Like, that looks like a pain in the butt to solve by hand. I'm not really interested in doing that on the SAT. So what I'm going to do is just go ahead and plug this into Desmos. You can also solve these just by plugging them into your calculator. All you have to do is just plug them in the way they look. So you're going to do 2 in parentheses x plus 1. Don't distribute anything. Don't give yourself a reason to, miss any questions. X over x plus 5 equals 1 minus 1 over x plus 5. So I'm moving that over to show the people on ticky-tack. And you can see that you get the vertical line that I do not like, but even with that vertical line, this is so much easier to read than by doing this by hand. So even then I can pretty much see that it's 2. But once again, if I just want to get rid of this vertical line, all I have to do is just move it over and just change the sign. And I get the nice line. The answer is 2. But that is much, much faster than doing it by hand, which is really what we're trying to do here on the SAT, is to move quickly and efficiently. There is no pride in doing it the slow way. Do it the quick way, and you'll be able to get a lot more points on your SAT. All right, I see a lot of people hopping on. I am walking through a guide that you guys can find using wherever the links are. You can click it, you can download the guide and follow along with me, and then complete this on your own time. All right. So with that, please download the guide, follow along with me. Let's get your SAT scores up. Move it on to the next question. You're going to see this one here. And the reason I put this question in the guide is because a lot of students get flustered, get confused when they see T. They're like, oh, I don't know what to do. Well, it's like, okay, well, what would normally go in place of the T? Well, it would be X, right? Not too complex. So whenever you see a constant like that, and it's clearly set up like it's an equation, just replace that T with an X, because DESMOS can graph X and Y values. When you have a constant like T, you pretty much have to give it a value. It's not going to graph it. So in this case, I just want to type in 5 and then in parentheses, X plus 3 minus 7 and then X plus 3 and set it equal to 38. So let me show you guys on TikTok. This is what I'm talking about. Just replace those T's with X's. If I zoom out, I can clearly see that I get a solution in 2 seconds, that it's negative 22 would be the answer. And so obviously, if you want to get rid of these vertical lines, because sometimes they're annoying, just switch it over. Move that negative 38, move it over to the other side, and you're going to get a line now. But once again, you get the solution incredibly fast, that X equals negative 22. You're not going to have to distribute the 5, distribute the 7, and then do all that multiplication and addition. You just go ahead and plug it into your calculator. All right, now we're getting into the fun stuff. So I'm assuming this was boring. Like, this is basic entry-level DESMOS knowledge. If you didn't know this, fantastic. You just got some points on your SAT score. But we're now moving into the more complex things like absolute value or inequalities. And so these are a little bit different, and there's some background knowledge you need to know for both of these. So for absolute value, treat it like anything else. It's not special. You just want to plug this into DESMOS. And so you can see your absolute value over in your bar has 2 vertical lines with an A in between. That stands for absolute value. But I use the shorthand key. So you just want to type in 2 and then absolute value, 4 minus X, close it, then plus 3 and 4 minus X again. And then you want to do equals 25. And so showing the people on TikTok, this is what my graph looks like. So taking a look at this, I can see that I have 2 vertical lines. I do not like my vertical lines. I do not like them there because once again, they do not give me points. So you need to know how to troubleshoot DESMOS. You just got to move this 25 over to the other side by subtracting it. So we're just going to get rid of that, subtract 25, and I have gotten rid of my vertical lines. It's that easy. Don't let it fool you. But then right then and there, I get my 2 solutions. So this question in particular is asking, what is the positive solution? So in this case, the positive solution is going to be 9. And it's that easy. look at that. Look at the math you would have had to do for absolute value questions, but instead you can just plug it into Desmos. Fantastic. That's all you need to do. These are some of the easiest questions to do on the exam, thanks to this calculator. Let's take a look at inequalities. So inequalities are a little bit different. Inequalities have some background knowledge that you need to know in order to get them right. So I'll do my best to show you using the calculator. So with inequalities, and this will just be an example, where let's imagine we have 3x greater than 5. You see that we have this entire shaded region. The shaded region is going to be all solutions. So whatever points are in the shaded region will be numbers or points that satisfy the inequality, or they'll be the correct answer, right? Excuse me. And so they'll be the correct answer. So you want to make sure that you put your points in the shaded region. The correct answer will be in the shaded region. Now, the second thing you need to know for inequalities is that you see how this is a dashed line? That means it is a greater than, right? A greater than 5. That means that any point that shows up on a dashed line is not a correct answer because it must be greater than or less than. I'm comparing this to greater than or equal to. You see how it's a full line? The full line means that any point on the line is okay. That is a correct answer. So just a subtle difference in inequality questions that you need to know. But without further ado, let's go ahead and try to answer this. Which point in the xy is a solution to the given inequality in the xy plane? And so in this case, we see y is less than negative 4x plus 4. And so we want to go ahead and plug in A, B, C, and D and see which ones satisfy the inequality, or which ones would be in the shaded region. So let's go ahead and type that in. Y is less than negative 4x plus 5. So what I want to do here is just plug in those points. You can just plug in points by typing them in the way they look in the answer choices. So what you can do is just type in negative 4, 0. Here, I can pan over. You can kind of see that. You can just type in negative 4, 0 and click label. And you can see whether it's in the shaded region or not. So in this case, A would be a solution because it's within the shaded region of the XY plane. And if I typed in the other ones like 0, 5, 0, 5, label, I can see that that can't be right. 2, 1, label, and then 2, negative 1, label. So for the people on TikTok, let's take a look at all the points. This is a little clustered, but we can see that negative 4, 0. Here, let me move that. See that negative 4, 0 is over here well within the shaded region. Therefore, it would be a correct answer. 0, 5 does not satisfy the inequality because it's over here outside of the shaded region. Same with 2, 1, and same with 2, negative 1. We can see the points do not fall in the shaded region. So A must be the correct answer for this question. All right, so let's pause there. Any new people hopping on, go get the guide. It's going to be included. It's free. There, wherever the link is on YouTube or TikTok, I have a guide that you're welcome to download and go along with me. So at that point, we covered all of the single variable equations on Desmos, including absolute value and inequalities and square roots and fractions, all solved incredibly easily on the SAT with Desmos. So let's go ahead and talk about sliders. So now we're getting much more complex here. These are going to be more difficult questions that are going to have some layers to them. So I'm going to help give you guys the background knowledge you need to solve these types of problems and hopefully make it a lot easier for you guys to understand. So sliders. Sliders, if you're ever given a constant, so if they ever say you have a C, if you have A, if you have B, and they want to assign a value, that's what you're going to call a constant because the value doesn't change. It's a constant value. And so for those, you're going to put a slider. If you're changing the value of the constant, you wiggle it around. You see this point right here where it says add slider. That's how you add the slider. If you see this part where you have like a blue dot, That's what you move side to side to change the value of your constant. Then if you can only given a range of -10 to 10 and you want to increase it, you just click the 10 and then put in the number that you want. And so that's how you increase the slider. But let's go ahead and practice these questions. So let's take a look at this one here. In the given equation, C is a constant. The equation has exactly one solution. What is the value of C? Okay, so let's go ahead and type in this equation into DESMOS and go from there. So we're going to have -2x squared plus 20x plus C. And so once you put that plus C, let me show the people on TikTok. Once you put that plus C, you want to make sure you hit add slider. That's incredibly important because if I don't do that and I just hit =0, it just says, yo, dude, like, what are you doing? We can't do that. And so you need to make sure when that slider thing pops up that you click it. And so you're going to be able to access the slider and move it around. So this is what I was talking about where it's a constant. So it's not an X and Y value, but this is basically you making the number different, and it shows you the graph and how it would look if C equaled -5 versus is C equaled 1, 6.4, and so on. How to increase your slider is you see this -10 and this +10 on the edge. You just want to click them. And then I can increase my range from -100 to +100. And now my slider is much, much bigger. If I zoom out, you can see I have a parabola here. And I can make it much bigger and much smaller, moving it around. All right? So this question in particular is asking me, which equation has exactly one solution? So let's talk about that real quick, what solutions mean. And so in this case, this has one solution, right? So a solution, if you're dealing with one line, it's where the line crosses the x-axis. So that's how we found the answers for the rest of the problems, is by looking at solutions. So we want to see where it crosses the x-axis. So currently, how many solutions does this have? This has no solutions. It doesn't cross the x-axis. In this case, how many solutions does it have? 2, because it crosses the x-axis at 2 points. And so it's asking us, when does it have exactly one solution? So lucky for us, it gives us answer choices. So in this case, I can just kind of go top down. I can look at A and it says -68. So I can type in answer choice A, -68. And when I see that, there are no solutions. So therefore, it's not going to be A because we're asking for one solution. So let's take a look again. We can see that B over here is going to be -50. Let's go ahead and type that in. And I can see that it touches the x-axis at 1 point. So how many times does it cross the x-axis? It crosses at 1 point, therefore there's one solution. So B is going to be the correct answer for this question here. And then if I wanted to double check, I could type in -32. I can see there's 2 solutions here. If I typed in 0, I can see there's 2 solutions as well. Now let's take a look at the other problem. Now this one is genuinely a difficult problem. I think on practice test 10, there's a very, very similar question. So this is a very real SAT problem that you might get on the exam. In the given equation, C is a constant. The equation has no real solutions if C is greater than N. So what does it mean to have no real solutions? It means you don't cross the x-axis, right? So what is the least possible value of N? So what is the lowest N could possibly be? That if C were greater than it, there would be no solutions. Let's try it. Go ahead and type that into your calculator. X squared minus 34x plus C. And then of course, do not click =0. Go ahead and add C as a slider. And then I'll go ahead and share my screen for the people on TikTok. Take a look here. We can see that right now, there's 2 solutions. So remember, we want to figure out what the heck C is when there's no solution, so then we can figure out what N is, right? So I want to move this around, but I'm kind of stuck, right? There's only such a range I can move this to. I need to expand my range. So once again, you do this to expand the range of your slider by clicking the -10 and the +10. And then I can set my range. I'll just do -100, and then I'll do +100. And then moving that around, it's not big enough. So I can go even bigger. I'm going to go -300, +300. So now I have a way bigger range. And you can see that did it. That did the trick. So now I can see that around 290 is when I'm beginning to have no solutions, right? Because it doesn't cross the x-axis here. And so what I want to do is I want to go ahead and just click in the tiny different numbers. So 287, I see that there's 2 solutions. 288, I see that there's 2 solutions. 289, I see that there is. Now we're getting close. 289, there's 1 solution, but at 290, there's no solutions. So at 289.1, how many solutions are there? Zoom in. 289.1, there's no solutions. So I know when C equals 289, there's 1 solution. But if C is any value greater than 289, that means that there must be no solution. So taking a look back at our question, it's asking us, the equation has no solutions if C is greater than n. What is the least possible value of n? So if at 289 there's 1 solution, but any number greater than that for C, there's no solutions, that means n is 289 because it is the smallest value that C can be before there are no solutions. So the answer to this question is 289. All right, we're moving on to system of equations. So really, we got a couple more, and it's going to get harder as we go. So please pay attention. Please download the guide. These are going to be pretty difficult to do if you're not doing them in DESMOS. So go where the links are, download the guide so you can follow along with me. I'm on the system of equations section, and this is going to be pretty much a free worksheet for you guys. Follow along. All right, it's going to be cool. Oh, never mind. I'm seeing comment DESMOS to get our SAT prep guide. So comment DESMOS, people. Comment DESMOS, go where the links are, find the DESMOS thing. I'm sure you can do it. But without further ado, we're going to start with systems of equations. So there is background knowledge you guys need to know for systems of equations for it to make sense with DESMOS. So there's going to be, so remember how solutions before were when a line crossed the x-axis, right? So imagine we had 3x plus 4. If I zoom out, I can see that we have this solution, right? And normally with one line, it's going to be where it crosses the x-axis. But with 2 lines, it's different. With 2 lines, it's going to be where they intersect. So in this case, there's going to be really 3 scenarios that occur. There's going to be where these 2 lines don't intersect. We call these parallel lines, and that's a no solution, okay? Where they do not intersect, that's no solution when dealing with 2 lines. But if they do intersect, so let's change this to like, let's make it a reciprocal, -1/3. If they intersect, that means there is 1 solution because they intersect at 1 point. So the answer would be where they intersect. And then there's the third option. So they can intersect none, they can intersect 1 or 2 times, or you're going to get something where they intersect infinitely many times. They call this all real numbers. This just means that it's the same line. So if there's all real solutions, you're just saying that it's the same line on system of equation problems. So remember, we have 3 scenarios. We have where they never intersect. We have where they intersect for all real numbers. And then we have where they intersect a quantifiable amount of times, 1 or 2 times. All right. But with that information, we can go ahead and practice these problems. So let's take a look at this first one. The solution to the given, oh, look at that typo. The solution to the given system of equations is x, y. What is the value of x times y? This is going to be a very, very common SAT problem. These systems of equations are very common, super important to know. And so we just need to type in both of these equations in DESMOS and see where they intersect, because the intersect will be the solution and you just need to take the x and the y value of where they intersect and multiply them together to find the answer. So go ahead and do that. I'm going to type mine in now. 5x plus 14y equals 45. And then we have 10x plus 7y equals 27. And so I'm going to show this to TikTok. So once again, we have two lines. The solution is going to be where the two lines intersect when dealing with multiple lines. I can see that they intersect at 0.6 and 3. So if you ever want to remember what these points are, you can just go ahead and click this export point to expression list. By clicking it, it just moves it over here. That's easier because they're asking us what's x times y. So I can just do 3 times 0.6 and get 1.8. So 1.8 will be the answer to this question. Remember, where they intersect, x and y values. And for this particular question, we wanted to multiply them together. So 1.8 is going to be the correct answer. Now, take a look to the question to the right of it. That's a doozy. So this is also a very, very common question on the SAT where they're going to give you, let's say, fractions, because they don't want to make it easy, right? But with DESMOS, this one to the right is actually way easier than you think it would be. So just go ahead and it's a little tedious, but just plug it in DESMOS and then make sure you get that slider P there and then I'll show you guys how to do it. So I'm going to go ahead and type it. It's going to take me a second. 3 over 2y minus 1 over 4x equals 2 over 3. There's really no fast way to do this. It's just kind of brutal typing. All right. And then we have 1/2 x for our other one, plus 3 over 2. Oh, wait, I missed one. Make sure you type it in correctly because it's super easy to mess up. Equals py, going to set a value for p, and then plus 9 over 2. Perfect. All right, I'll give you guys a second to follow along, but this is what mine's looking like. As you can see, I'm given two lines. I got my purple line and my green line here. And the question is stating that these have no solution. So what does it mean to have no solution? It means that they never intersect. This is incredibly important. No solution means they never intersect. And so what I want to do here is I want to move this slider around to make it so P becomes a value where these lines never intersect. And I can see as I do that, they kind of not looking too great. I see at 7.1 they intersect here, but since this is a little tight, I'm just going to go number by number. So I'm putting in 6. Let's see if they intersect. Oh wow, is that like a lucky guess? There is no luck involved in DESMOS. Let me double check. So what I like to do to double check is I like to switch it to another number. If I type in 7, do they intersect? Yep. At 7, they intersect. But at 6, I can see that these lines never intersect each other when P equals 6. So I like to go to the far ends just to check. Yep. And they never intersect. So it looks like P equals 6 when these lines have no solution. So they never intersect when P equals 6. So 6 would be the correct answer to the question. But you can see how much time that would have taken you on the exam and how quickly we just did it together now. And so that's a tough question. Moving on. All right, so let's go ahead and do this one. In a given equation, A is a constant. If the equation has infinitely many solutions, so what does that mean? There's no solutions, one solution, infinitely many solutions, right? Infinite many solutions means that these are the same line, right? And so this problem's tricky because it's one of the easy problems you can do that freaks DESMOS out. And so why this freaks DESMOS out? Well, you'll see. So let's go ahead and type that equation into DESMOS. We're going to do 2x plus 16 equals a x plus 8. And you see DESMOS is tweaking. Why is DESMOS freaking out on me? Well, we need to assign a value, right? Let me see. The slider button never pops up for this. So let me show the people on TikTok. When you type this in, normally when you put in a constant, so say plus A pops up. They say, hey, add a slider for this, right? But in some cases, if I do x plus 8, it never popped up. Like they never gave me an opportunity to put the slider in. So now I have this error sign and that's a problem. But no worries, here's the solution. You just want to troubleshoot. You can basically say, hey, Desmos, I'm telling you this is a constant. I'm just going to put 10 in for A, and then that'll solve that issue. And then you move it around. But this is a really tricky problem on Desmos because when you move it around, the line doesn't really go anywhere. It just kind of flickers when I get at 2, right? So once again, I really hate vertical lines. I do not like them because stuff like this happens where you're just super confused. It's hard to interpret. I know 2 is a special number because the line disappears. Not digging it. So what I'm going to do is I'm going to go ahead and just like move this over, subtract it. And in this case, once I do that, I finally get the line that I'm looking for. So remember, I've turned this instead of 2 lines, I have made it 1 line, right? And so when dealing with 1 line, the solutions are where it crosses the x-axis. So in this case, it's at the x-axis the entire time, right? Wouldn't you say if at every value this hits the x-axis, you would say it's infinite solutions, right? Because as I move it, I can see that it only hits the x-axis at 1 point unless it's 2. So therefore, when A is 2, there's infinite many solutions. While Desmos is great, you need to practice with it and practice troubleshooting issues with Desmos. Good job. So A is 2, if y'all were wondering, that's the correct answer. Now let's do another challenging question. Let's go to the one to the right. So this one is pretty confusing to the people who are not Desmos trained. But at this point, you are now solving very hard problems. The SAT considers these hard on exams, so they're worth a lot of points. And you can just solve it with a calculator. It's pretty sweet. So let's go ahead and take a look at this one. In the xy plane, a line with equation 2y equals 4.5. It intersects a parabola at exactly 1 point. If the parabola has the equation y equals negative 4x squared plus bx, where b is a positive constant, what is the value of b? Perfect. So systems of equations, they've given us 2 separate equations here. How did you fix the law? Oh, if you guys I'm seeing questions. So someone asked a question about this question here. How do you fix it so the slider wouldn't make it the line flicker? So what you want to do is you see how it equals a x plus 8. You just want to move it over. So you want to do 2x plus 16 minus a times x plus 8. That's how you do it. But anywhoosies, moving back to this question. Sorry about that, guys. What you want to do is type in both equations first. So I'm going to type in 2y equals 4.5. Because I don't like to mess with equations until I type them in. And if something's wrong, then I'll move things around. But sometimes they work perfectly fine. Because in this case, when I type in 2y equals 4.5, it just gives me a flat line. Then I'm going to type in the next one. Negative 4x squared plus bx. And I'm going to build a slider for b. So now I'll show the people on TikTok. This is what I'm looking at right now when I type these in. 2y equals 4.5. You get this horizontal line here. For negative 4x squared plus b of x, you're going to get this parabola. And so they're asking me, what is b when there's one solution? So in this case, one solution when dealing with 2 lines is where they're going to be intersecting at 1 point. And so what I want to do is just move this slider around and see where I can get it to intersect at 1 point. Let me see, does it specify? It does specify b is a positive constant. So b has to be positive. And I noticed that because when I was moving it over to the negative side, I was like, oh, it hits it on both. But it said b has to be positive, so we know to go to the right side. And really, I'm just going to move this slider until I see it touch at 1 point. And at this case, I see when b equals 6, hits it at 1 point. 6 is the right answer. Easy peasy. Once again, these are considered hard questions on the SAT. So this is worth a lot of points when you take the exam. And hopefully you guys can see how easy these are. So really download the guide, practice this, go through it multiple times. I can guarantee like you're gonna get way better at using this calculator. All right, let's go ahead and do this last one. So for reference, when you're dealing with inequalities, what's gonna happen when you use that less than or greater than sign, you're gonna get these shaded regions showing up on your graphing calculator. Just remember that the shaded region is where the correct answer should be. It should be in the shaded region. Now, when dealing with two inequalities, you just wanna make sure that there is gonna be two shaded regions. The answer that satisfies both of them is gonna be in the shaded region where they overlap. Here's what I mean. So go ahead and type those in for this problem. Don't move anything around, don't worry about it. Just type it in as is. And so type this in, and I'll show TikTok. This is what my graph's looking like. So once again, I mentioned the shaded regions. So when dealing with one shaded region, so let's turn this off, all correct answers would be in the blue. But now that there's two, the correct answers are going to be in the shared region. So we can see there's a blue and a green, but an answer should align in the shaded region of both of them. And so what you want to do with these is you just want to take a look at the points given to you and type them in one at a time. We have -2, -1 as our first point. So -2, comma, -1. I can see that that's outside of both shaded regions, therefore it cannot be a correct answer. Next, we're going to have -1, 3. I can see that is outside of both shaded regions, therefore it cannot be the correct answer. Now we're going to go to C, 1, 5. 1, comma, 5. And then that's going to be outside of both shaded regions. So I really hope D is the right answer, or else I did this wrong. So let's type in 2, -1. And like I thought, it's going to be in both shaded regions down here. And then we can label them if you really want to like decipher between which one's which. This is going to be 2, -1 over here. As I can see, the rest of these fall outside of either shaded regions. So these are going to be incorrect. And -2, -1 is going to be the correct answer for that question. But that's how you do these. I mean, that's systems of equations in a nutshell. That's pretty much every single type that you're going to see on the exam. Now we're getting into really hard stuff. So this is probably the stuff, if you've watched basic videos, they definitely cover all of this that we just went through. This should be like level 1 systems of equations, about level 2. This is going to be level 3. This is pretty much as advanced as it gets for the SAT. People who do, fancy regressions, I think is cool. I mean, like, this stuff is helpful. These types of problems totally pop up. But basically, we're going to move over into translations and composition functions. And so basically, this is what's going to happen. You're going to get two equations. You're going to get f of x and g of x. And what SAT wants you to do is it's going to say, how do you combine these? What is the graph of f of x minus g of x? What is like 3 when that happens? Normally, you have to do this by hand. Incredibly confusing, not fun, would not recommend it. 2 out of 10, would not recommend. What I want to do is go ahead and plug it into DESMOS. Here's how. So you see how it says f of x equals x plus 7? You want to type in that f parentheses x equals x plus 7. Because what you're doing is you're telling DESMOS, hey, this is the name of that equation. Here's what I mean. And then that'll help you later on. So for the people on TikTok who can only see half my screen, this is how I would type it in when they ever give me an f of x. F of x equals x plus 7. I'm telling DESMOS that whenever I type in f of x from here on now, it means x plus 7. And so I want to type in g of x as well. G of x equals 7x. And now it's asking me, what is 4 of f of 2 minus g of 2? So that might not even make sense to some of you, because that's confusing stuff. But what it basically means is f of x is x plus 7, right? G of x equals 7x. Now I've told DESMOS, hey, you know that f of x stuff I was talking about earlier? I want you to plug 2 in for x, and then whatever number you get, I want you to multiply it by 4. Then I want you to subtract whatever g of 2 is when x equals 2 for g of x. and then tell me the answer. You can see both my screens on my YouTube channel because my current streaming platform decided to go kaputs on me. And so I'm sharing TikTok with one screen. Sorry about that, guys. But YouTube, you can see both. But in this case, you can see that that's how these work. You basically just tell Desmos what each equation is and then type in what that question is asking for and let Desmos do all the hard work. But that was a relatively simple one. Let's take a look at the actual hard one. So this is much more like the ones you'll see on the SAT. It gets that. This is my easy entry level one. In this case, the answer is C, by the way. But this is much more like the SAT because these are considered very difficult questions. So go ahead and do this one on your own. Type in f of x equals 1/4 x minus 9. Then g of x equals 3/4 x plus 21. And then you want to create a third graph by saying, hey, I have this new third graph, h of x. It is f of x plus g of x. And then it'll graph it, and you want to find that x coordinate. So in this case, I'm going to go ahead and type that into my Desmos. So I'm going to type in f of x. So f of x equals 1/4 x minus 9. And then I'm going to get g of x equals 3/4 x plus 21. And so for the people on Desmos or on TikTok, I'll show you guys what I'm writing in like 2 seconds. All right, so I'm gonna show you guys. This is what I'm cooking. So if you can see that I've told Desmos, hey, f of x equals this, g of x equals this. I want a third equation, h of x, and it is going to be the same line as if I combined f of x and g of x together. And guess what? It flipping graphs it for you. Look how insane that is. Look at how annoying that math would be if you had to add all these together. But instead, it not only added them together, it graphed it for you. And so the question here is asking, well, what's the x coordinate of the x-intercept of y equals h of x? I can find that in 2 seconds. It's -12 right there. Because I can see that this red line is my first equation, blue is the second, and then h is the combination of both. Boom, right there, -12. Easy peasy, takes 2 seconds. Now you've saved multiple minutes on the SAT and you're a lot better for it. So that's how you do composite functions. You really just want to label using f of x and g of x and then combine them. All right, so moving on to the next topic, equivalent expressions. So really we only have 2 more topics, regressions and equivalent expressions. And they're both pretty simple. They kind of like build off of the other topics. But if you haven't already, go ahead and download the guide. Either comment Desmos down below on YouTube or on TikTok. You can find it in my bio. You can download this guide, do this work yourself, or follow along with me during this. All right. People on YouTube comment Desmos, I'm pretty sure. Maybe I'm wrong, who knows? But we're going to begin equivalent expressions. So basically, equivalent expressions is a fancy way of saying it's the same graph. It's an equivalent expression, same graph. It just means that like, hey, I had this graph over here, and I want you to do some factoring or simplifying to turn it into the same thing, just looking different. That's it. But what that means for you guys using Desmos on the SAT is, what this means for you guys using on the SAT is when you graph them, they should create the same line or give you the same equation or answer. Here's what I mean. So go ahead and type this into Desmos. What's going to happen is that A and C are not X and Y values. So it's going to ask you to give a slider. And so in this case, with the slider, you're going to want to give it some points. It actually doesn't matter what points you give it. Just say A is 2 and C is 3. Doesn't really matter, but go ahead and type that into your calculator. We're going to do A plus C to the power of 3 times square root of A plus C. So I'll show you guys over on my screen what I'm looking at. So in this case, they give me a slider. And so I can make A1. You can't really make them negative because it's a square root. and you can't take a square root of a negative number, but I prefer doing smaller numbers, like C is 3, A is 2, whatever. And it gives me 25. But in this case, if I move over, I can see that one of these should be the equivalent expression. And so in this case, I get to type in A, I can type in B, I can type in C, and I can type in D into Desmos, and it will do the math for me. Here's what I mean. So A is A plus C, right? So I can go ahead, oh, come on. I can go ahead and type in A plus C. And when I do that, I get 5. That means this is not the same equation. This gave me a different answer, so A can't be correct. Taking a look at B, it's A squared plus C squared. So if I could just go in here and I go squared plus C squared, I get 13. Therefore, B can't be the right answer either, because it does not give me the same value as my top equation. Taking a look at C, I get A squared plus 2AC plus C squared, so A squared plus 2AC, and I get the right answer. Therefore, these must be the same equation. But I'm going to double check by typing in D. It's just A squared times C squared. So if I just do A squared times C squared, I get 36, and that's not the correct answer. So I know this C will be the correct answer because it's the equivalent expression. It is the same function, therefore it gives me the same value when I type in the same amount of numbers. Cool. Let's go ahead and do that last equivalent expressions, and then we'll get into regressions, which seems to be a hot topic on Desmos or on TikTok. People like the regressions, but I'll show you guys how to actually use them on the SAT. Most stuff that you guys see, I don't think is very realistic, but I'll show you how to use these on the SAT that'll actually help you. But before that, let's go ahead and do this last question here. So go ahead and type that into your Desmos graphing calculator. Three times 2x squared plus px. Make sure you put your slider in. And then you're going to want to do plus 8. Ooh, very nice. And then you do minus 16x times p plus 4. And that's going to be your first equation. Then you want to type in the next equation, right? 6x squared minus 155x plus 24. So normally what you'd have to do to solve this is you'd have to distribute the 3, distribute the 16x, then combine these together, and then you're going to set it equal to this, and then you're going to solve for p. That sounds horrible, so I'm going to show you guys how to do it in Desmos. So once you've plugged it in, it should look something like mine. Honestly, that's a pain in the butt, so I'll give you guys an extra second to plug it in. All right, I'm done waiting. I'll show you guys how to do it. But also, if you downloaded the guide, I shouldn't have to show you, so go download the guide. But you can see that right now when p equals 1, these are not the same equation. So remember, they're equivalent expressions, meaning the same graph or the same equation. So it should show up the same on Desmos. So what you want to do is just move p around until they start to become the same line. And as you can see, as I make p larger, it's becoming closer to the actual graph. Ooh, and you can see right when I hit 7, they become the same graph. You can see because their vertexes are the same. These are the same graph. Therefore, when p equals 7, these expressions are equivalent. So 7 must be the correct answer for the correct value of p for this question. So B, right there. And then C was the answer for this one. So yep, that's how you do equivalent expressions with Desmos on the SAT. And then last but not least, we're moving to the last section. And now if you have not grabbed the guide, go ahead and grab it because we are about to finish it up. And this is probably the most complicated part. This is the part my students have to review multiple times when I'm tutoring them for the SAT because you just forget. There's a lot of buttons. And so this is the one where you want to pay attention to. And I have no idea if this is Algebra 2, Alec. This is the SAT math. Fun fact, if you guys haven't taken Algebra 2, yeah, push off study for the SAT. Algebra 2 is like a lot of this stuff. But anywhoosies, if you guys have any questions, let me know. I'm looking at my TikTok comments right now, so I can actually see them. There's two Alex talking to each other. He's got the #1 gifter badge. All right, so we're talking about regressions here. And if you, once again, if you haven't downloaded it, go ahead and download it. It's a good guide. Maria, didn't you say a mean comment earlier about what this video is? And now you're asking me a question, but I'm just messing around. I don't know what mathematics for college algebra is. Just make sure you're taking algebra 1 or 2, because that's super important for the SAT. But without further ado, let's talk about regressions. So basically what regressions are, regression is a fancy word for line. That's it. Like equivalent expressions just mean same line. Regressions just mean line. Like it's just telling me what the line is. So you know how you can find slope using 2 different points, and then you can find people in the comments made me laugh. You know, you can find the y-intercept by plugging in points. Basically, Desmos can do this for you. But how you do it is a little bit different. As you see here, you see this plus sign. You click it, and you can build a table. And what you want to do with that table is you just want to plug in points. So for example, I'm doing this not based off the questions. If I plug in 0, 3, and I plug in 1, 5, you know you can do y2 minus y1 over x2 minus x1, find the slope, plug in x and y to find the y-intercept. Desmos will just do this for you. You just hit this, and it gives you the linear regression, 2x plus 3. Like it tells me right here. And so it's pretty awesome. Oh my God, I'm so sorry for people on Desmos or TikTok. Here you guys go. I'll restart it. What you want to do is click this plus sign, table, plug in your points. Let's do 0, 3. Let's do 1, 5. And you want to click this button here. It's going to say add regression, and then you're given a regression. So really, you never have to actually find the slope or anything of a line. You can plug it into Desmos, into this table, and Desmos will tell you what it is. It's pretty sweet. But you can do this for incredibly hard problems. Normally, for something like this, you should be able to do it by hand. That's something pretty much required. But you can do this for quadratics. So say this was a quadratic, you get 2x squared plus 0x plus 3 for a cubic, and then for exponential. And then it'll give you the equation for the exponential if it connected these 2 lines. So yeah, let's use these for these questions. And then the steps are right here that I covered. They're on the Desmos worksheet. So let's take a look at this last one. For the linear function f, the table shows 3 values of x and their corresponding values of f of x. Function f is defined by f of x equals ax plus b, where a and b are constants. What is the value of a minus b? So in this case, we're given a table here, and they're asking us to build a line. Normally what you'd have to do is add these points together, solve for the slope, solve for the y-intercept. But what I'm going to do instead is just put in a table into Desmos. Click the plus sign, hit table in the dropdown, and plug in the points. 1, then -64, and you want to do 2, 0, and then 3, 64. And then in this case, they specify that this is going to be a linear function. So we know when we hit our regression button, we want to keep it as a linear regression. And then it tells me what a and b are. It tells me 64x minus 128 would be the equation that creates this line. And so what I want to do, since this is asking me what a minus b is I just want to do 64 minus -128. So 192 would be the correct answer for this question. So 192, I want to go ahead and make a table, plug that in, get the linear regression. Now, here's where it gets tricky, all right? Take a look at the one to the right, try it out. Go ahead and type in these points. We're gonna have 2 different lines here, so we're combining 2 different topics. For line H, the table shows 3 values of x and their corresponding values of y. Line K is the result of translating line H down 5 units in the xy plane. What is the x-intercept of line K? So in this case, we're given points for line H. So what we need to do is build a line for line H, shift it down 5 units, then find the x-intercept. Doing this by hand is incredibly taxing. It's not fun to do on an exam. So I'm going to show you how to do it in your graphing calculator. So go ahead, type in these X and Y points into your table, and then I'll show you how to do this. So open your table and type in your X and Y. So it's gonna be 18, 130 is your 0.1. It's gonna be 23, 160. And then it's gonna be 26, 178. So I typed that in. I'll give you guys a second to catch up. This is the last question, so make sure you get it right. All right, so we have this. All right, does it specify? All right, so we have line H here. So we're gonna go ahead and build our line. So we have 6x plus 22 is gonna be what builds this line. But remember, we need to make sure that we have shifted it. So we're gonna do hx equals 6x plus 22, right? And then we want to shift it down 5. So I want line k of x equals h of x shifted down 5. And so now we get our new line, k of x, by shifting h of x down, but we found h of x by plugging in these values here for this question. And then if I zoom in, I can find the x-intercept. It actually grabs it for you. It's going to be negative 2.833333. All right, looks like the live is wrapping up. And TikTok is making me verify who I am. And I think I messed it up. I'm having to drag a puzzle piece into a hamburger. All right, perfect. Sweet. But this is it. I mean, the answer is negative 2.833. So in this answer, I'm pretty sure that looks like A. So if I type in negative 26 over 3. No, that is not it. Huh. Let's find out what the answer is. This is 17 over 6. Thank you. So negative 2.833 is going to be answer choice D. I just had to plug them each in to figure out which one was right. Might be. Didn't know it was a fraction, but that's okay. Whenever you see fractions in the answer choices, you can just turn them into decimals. But that is it for the live. If you didn't download the guide, go ahead and download it, comment Desmos, or go to where the links are. But that wraps it up. And if anyone is looking for SAT tutoring, I actually do free SAT classes. So if you're interested in that, just DM us, ping us, free SAT classes, or you can meet with me one-on-one. I'm happy to tutor you for the SAT, bring that score up and get your dream SAT score. And we do a free score review as well. So if you're interested in any of those, just reach us, DM us, or comment down below, and we'll reach out to you. Thank you guys so much for tuning in. Hope you guys learned something. Oh, that was a lot of talking. Am I still live? All right, well, if anyone comments, I'll answer. I'll just kind of hang out until my